Hello everyone, my name is Roman, and in this video I'm gonna show you amplifier that I got from the Wondom company. It's quite interesting unit. It's called Jab5. It has two stereo amplifiers installed, so it has 4 output channels. It has class D Tda7498E chips installed inside here. Also it has integrated DSP unit, ADAO1701. So it's a quite interesting unit, and I'm gonna tell you about its features and about its capabilities. But first, let's check out TDA datasheet. Here you can see total harmonic distortion versus output power, and starting somewhere around 50 to 60 watts. After that, the distortion starts to grow exponentially. What it means, it is better not to go above that limit, otherwise you will face distortion. So no more than 50 to 60 watts per channel, otherwise you'll get a distorted output signal. Here you can see output power versus supply voltage, total harmonic distortion versus frequency, and FFT performance. That's how it looks. As for the inputs, this amplifier has simple line input. You could order cable kit which has this auxiliary input, and you could plug it into your amplifier and simply plug your mini jack and use the integrated ADC like that. As for me, I've ordered separate board. Here how it looks. It's the analog signal to I2S converter, which works much better than the integrated ADC. So I'm gonna be using this one. I'm gonna use this board. Also, this amplifier has Bluetooth 5.0 inside installed. Here is this Bluetooth module. Also, it has this separate connection for the antenna. So if you need long distance range, you could plug antenna here. A codec that it uses is Aptx-HD, which has somewhere around 500 kilobytes of transfer speed, and it will be enough for the YouTube and streaming MP3 files. Also, this amplifier has I2S input, which I'm gonna use. You're basically transferring a digital signal to this amplifier. So here you plug your I2S board. I think it's here, yes. You could plug it, you could plug USB to I2S card and transfer a signal from your PC or your computer or your laptop to this board without using ADC. Or you could plug another board and transfer I2C signal to this amplifier. So basically, auxiliary input, line input, Bluetooth, and I2S input, which is really great. Here you can see slots for the potentiometers, which later you could program in the Sigma Studio and basically adjust volume for the all channels or for the only one channel. You could write yourself a macros that one potentiometer could regulate crossover frequency or whatever you need. You just need to know how to program it in Sigma Studio. Here you have a programming port. This amplifier comes without firmware installed, so you will need this programmer unit. I have ICP5, and I'm programming it with ICP5 board. Later I'm gonna tell you how to program this amplifier and how to program the programmer itself. Otherwise this amplifier won't work since it comes without pre-installed firmware. Here you can see installed capacitors. It's like 63 volts, 3 capacitors on each side with 470 UF. Here you can see film capacitors. Yes, you can see it, 0.33. Here is a DC power input. I like about this amplifier that it has a variety of supported voltage. So basically, if you have some 16 volts amplifier DC output charger and power supply, this amplifier, with this amplifier you could use it. Also, if you have like 32 volts DC power supply, this amplifier will also work from this adapter. So it has voltage support from 10 to 39 volts, as I remember. Basically, one moment. Yes, it's 10 to 39 volts of supported power. If you're running it from the battery, there is a wide range of supported voltage, so no problem. Here you can see speaker output for speakers. So basically, you have a connection diagram on the website available, and you can use this board in mono mode. Each of the amplifiers 2.1 mode. It's like this amplifier will work in stereo and this amplifier will work in mono. Or you could set it for both amplifiers running in mono mode. Also, there is a I2S output. To use I2S output, you will need second Jab amplifier, and you need to set one amplifier in master mode and second one into slave mode. You can see here the switch, which you can choose which mode it uses. Currently I'm in master mode. In master mode, line input is working and Bluetooth. In a slave mode, I2S input is working. So basically, you could hook up second Jab amplifier and have output for the 8 channels. Or you can use it for a 3 amping. You could use one amplifier in stereo mode, one amplifier in mono mode, and the same way on the other Jab5 amplifier. In Sigma Studio, it is just duplicating stereo signal. So basically, you're gonna program this port, and with I2S, it's gonna send same signal to another Jab5 amplifier, and you could same way program it as you wish. Here you can see there is some space. If I put this port on a table, there's a small hole beneath it, so it's great that you won't get your board shorted. It's actually quite good. This board is actually quite good. I'm gonna use this board for the bi-amping project with FIR filters. And now I'm gonna tell you about the benefits of the fill filtering and bi-amping your speakers. But first, let me explain how to program this unit. In order to program Jab5, you will need a programmer. Currently, I'm using ICP5, but ICP1 or ICP3 will be suitable. The programmer itself comes without installed firmware. So if you plug it into your USB port, the red indicator will glow. So you need to program your programmer first. In order to program your ICP unit, you will need Sigma Studio, you will need Windows 10 driver, and you will need MuMax for Jab5 software. After you have everything, install the driver and run the Jab5. After the Jab5 software is open, in order to program this ICP5, you have to press and hold this button, and at the same time plug your programmer into your PC or laptop USB port, and your LED will start blinking. After that, in upper right corner there will be glowing update firmware button. Just press it and your firmware will be upgraded, and you could program your Jab5. After your ICP unit is programmed, you could run Sigma Studio, and you can use stock project to flash it on your Jab5 unit. Just make sure that both switches, first one is in IIC mode and the second one in USB-I mode. So plug your programmer to your PC and run the stock project, which you could download from the manufacturer website. After that, you could power up your amplifier. Just make sure that when you're doing the first firmware upgrade, it's in the master mode. Otherwise, you won't be able to write first firmware. After that, you could use it in slave or master mode and flash the firmware without any problem. Also, make sure that your polarity is right. Check your polarity, and if your polarity is wrong, you will destroy your unit and it won't work. So make sure that your polarity is right. So now you could power up the Jab5. As you can see, it's in master mode, it's working, and everything is fine. So while running Sigma Studio, you plug your programmer into this port on the Jab5. Here we go. And just remember, if you're trying to connect, let's say I'll show you example. You see that the programmer has voltage. So basically, if I try to plug it in and program it from the Sigma Studio, it won't flash. I will get an error. So in order to make it work properly, first of all, connect your programmer to USB port like that. Power up your Jab5 unit, run Sigma Studio, and after that just connect your programmer with amplifier, and you will be able to program. Now, in order to flash our stock firmware, you will need to run Sigma Studio while our stock project is open, and you have to click link compile connect. After that, link compile download. Then go on the first tab hardware configuration, right click on the ADAO 1701 and click write latest compilation to EEPROM and confirm. And you will be flashing your first firmware, your stock firmware, to the Jab5 unit. If you'll get some errors and the firmware won't flash to your Jab5, it means that you did something wrong. Try reconnecting Jab5, try to power off your programmer, plug your programmer, plug your Jab5 and connect your programmer unit, ICP unit with your Jab5 unit, and try to do it once again. And make sure that your Jab5 is in a master mode and your ICP unit is set, as I told you, it's set into IIC mode and USB-I mode, and there should be no errors. So now I'm gonna tell you benefits about biamping your speakers. So first of all, if you're into DIY and you're building yourself stereo speakers, probably you will face problems with building passive crossovers. Because if you're trying to find right capacitor size and you enter some online crossover calculator, if you enter like 5000 Hertz crossover point for your tweeter and for your bass speaker, you will get slightly different capacitor sizes for the Linkmith Raleigh crossover and the Butterworth crossover. So there is a big chance of a mistake, and you don't know how your speakers will behave with a passive crossover, because you need to measure them, you need to know right impedance, you need to know all the other parameters, and actually it's really hard to build a passive crossover, and it's gonna take a lot of money and be really expensive. While at the same time, if you're using digital crossover, you could set any crossover point with 40 starting from 48 dB per octave crossover, which is really great. And also, if you're using linear phase crossover, you won't mess the speaker phase response, which will improve speaker impulse and step response as well. So you won't mess the speaker's phase. Also, if you're planning to power up your speakers from the battery, you will get less lost energy. With a digital crossover, your speaker won't produce frequencies above or under the crossover point, and if you're setting your crossover to 48 dB per octave, you will save a lot of energy. If you have a passive crossover inside, your amplifier will need to amplify a full range for the both speakers, and lots of energy will be lost. But with a digital crossover, you won't lose as that much energy, so you will save your battery power. Also, if you're into DIY, if you order speakers separately, most of the time the tweeter has higher sensitivity, so it will sound louder, and you won't be able to fix it if you have like passive crossover. But with a digital crossover, you could set gain and volume separately for all of your speakers, so you could easily put like -6 or -20 dB if you need for your tweeters, and match overall volume for your bass speaker and for your tweeter. Sometimes tweeter plays it sounds much faster than the bass speaker, and so they are out of time. And with a passive crossover, to fix tweeter working slightly faster, you will need to put tweeter backwards, or you will need to put your bass speaker forwards, which is most of the time not possible. But with a digital crossover, you could set a delay for your tweeter and phase match or impulse match as you wish. You could match them both like that with setting right time delay. So you could basically match the volume and the time delay for both of your speakers. What is great is that there is an adjustable PQ, so you could manually set the frequency response for both of your speakers, and they won't affect each one. So you could manually change the PQ for your tweeter and manually change the PQ for your woofer. And later on, based on the stock project, which you could download from the Wondom website, I'm gonna build a project for the linear phase crossover by amping speakers. So basically, and for the bi-amping my speakers. So basically what I did, my 85 speakers, best speaker didn't have any crossover installed, and my tweeter had only 3.3 microfarads capacitor. So I threw it out and hooked up the tweeter straight to the amplifier. And now I'm gonna measure my speakers, put a crossover using the Sigma Studio Room EQ Wizard and rephase program, and you could see it how I'm using it, and you could basically see how it's possible, how it's done. So stay tuned, and I'm gonna show you how I did it, and you could see a result. I did a little bit of tweaking, and that's how my final phase response and speaker frequency response look like. So I played with a delay, I played with speaker polarity, and that's how my step response looks like, and it's actually quite good. That's the advantage of bi-amping your speakers, that you could manually set right delay, you could fix phase response, and you could later in rephase you could adjust your phase if you need to. But this video is not about phase adjustment. I'm just showing you my measurements and my project. So this is the project I made from scrap, and basically you could use it, you could make it on your own, or you could use stock project without a problem and play music on your speakers with good quality, with great step response. Mine looks like that. So it's actually a quite good step response. And phase looks like that. So later I think I could fix it and make it look even flatter and even better. Yes. So that was my frequency response and phase response. And while I was filming this Jab5 video review, I received this Esp32 unit that I'm currently using for transferring audio over I2S and connecting this ESP board to LMS server and streaming media from the Wi-Fi, because Wi-Fi has better audio quality. And few things I forgot to mention is that a fan on this Jab5 amplifier doesn't work all the time. In fact, it works only when board needs cooling. So it's actually, if you're not running your speakers too loud and you're not using power supply over like 25 volts, I think you won't see your fan spinning. So don't think that it is broken. It just works when it needs to cool the board. And now I'm gonna play some music. I'm gonna stream some music to this Esp32 unit, and over I2S protocol it will transfer digital audio to this amplifier. So it's quite good, because I won't need ADC. I just use to stream digital audio to the amplifier, and after that it will amplify this audio. So I hope you like this video. You could ask your questions in comments. Now I'm gonna play some music, and that will be it. So if you have any questions, just ask it. My name was Roman Fedorenko. Thanks for watching. Subscribe and thumbs up. Goodbye.